Yo, what's up? Back on lead code. Let's get it. Okay, so yesterday I was doing some heap questions. Okay. Design Twitter. Find median from. Let's do this one. I didn't get a chance to look at this one, so let's get this today. Okay. Find median from a data stream. Hopefully, my stream is fine. Let me just check once. Okay, in here we go to YouTube, then we go to here. Yeah. Yup. Yes, sir. Okay. Perfect. The median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value, and the median is the mean of the two middle values. For example, in 2, 3, 4, the median is 3. In 2, 3, it is the mean of 2 and 3. Implement the median finder class. Initializes the median finder object. Okay, void add num adds the integer num from the data stream to the data structure. Double find median returns the median of all elements so far. Answers within 10 to the power of -5 of the actual answer will be accepted. Returns the median of all elements so far. Okay, so we definitely need some sort of heap because that's the topic. Easy. So in here, what do we need exactly? So we insert 1 to the data list, then we insert 2, then we find median. So okay, one way is to keep track of current number of elements in the data stream, so we can count that. That is easy. Is there any remove function? No, there isn't any remove. So we know n at all times, right? Now if n is even, it will be the two mid values, right? Can I create two heaps? Let's say this is a stream of very large pool of numbers. Dot dot dot. Or let's say for now this is the only data that we are talking about, right? Now how many are these? 0, 1, 2, 3, 4, 5, 6, 7, 8. There are 9 elements in here in the data stream, and I am only concerned with the middle two values. That's it, right? So can I create two heaps? One will be a max heap to take care of the first half of this data stream, and another would be a min heap to take care of the rest of the data stream. So I'm dividing the data stream into two heaps, and I am thinking of kind of maintaining those two heaps in such a way that the top of those heaps will always return the middle values. So we need some big braining here. So for example, initially one will come. So initially, okay, let's call them max heap, and min heap. When one appears, it goes to the max heap. Now 2 appears. Now n is 2. Okay, right? N is 2. Now, I see that the size of this max heap is 2, 3, 4, 5, 6, 7, 8. There are 9 elements in here in the data stream, and I am only concerned with the middle two values. So can I create two heaps? One will be a max heap to take care of the first half of this data stream, and another would be a min heap to take care of the rest of the data stream. So we need some big braining here. So for example, initially one will come. So now I see that the size of this max heap is more than the size of main heap, right? Or a better way to um, name these should be first half, and second half. Let's call it half 1 and half 2. This is a max heap, just to be clear, and this is a min heap. Okay, my DPI was high, that's why the handwriting was bad. Okay, now I see that the first half contains more elements than the second half, and 2 is greater than 1, right? And in the data stream they can come in any fashion, right? There is no order, right? Okay, let's take a better data stream. Let's call this 12, then 3, then 41, then 6, then 18, then 71, then 13, then 60. This is 7. Okay, now 1 appears. I push it into the max heap of half 1. Now 12 appears. Now 12 appears, right? 12 should also... Okay. Now since 12 is greater than top element of this max heap, means top element of half 1, it should ideally go to min heap, right? Okay, let's push it to min heap. Now 3 appears. Now the size of them are equal. 3 is less than the minimum element of half 2, second half, so it should come here. Now 41 appears. 41 is greater than 3, it should go here. Since this is a min heap, it goes like this. Now 6 appears. 6 is less than this. Okay, so at every input I need to check. Now let's say if this was 61, and this is 98. Now as you can see here, also when this is 61, I missed a point here, now 61 appears. 61 is greater than the top element of half 1, but they are equal in size. Since they are equal in size, the element that is being added will be will make n odd, means the total number of elements in our pool will be odd. And I want to make that program in such a way that in case of odd number of n, I should simply return the top of this half 1. So I'm keeping majority of elements in max heap in the first half. I can keep it in second half, it's just one way. So yeah, so now I need to perform some things here. 61 is greater than 12, right? So I push it to, okay, 61 is greater than 3, so I push it to here. Now since these are imbalanced, I pop out 12 and I push it to half 1. That's all I need to do. When 98 comes, I push it here. Yeah, so I simply need to balance these two, and majority of elements should be always in half 1. Basically size of half 2 should never exceed size of half 1. That is one condition that I'm going to enforce, and it should give me some solution, man. Let's see. So we need 2 priority queues. Priority queue of int, this will be half 1, This is a max heap. uh, Stores first half of the data stream, and then we have half 2. This is a min heap, stores second half of the data stream, right? Now simply what do I need to do in add number? Okay, if half 1 dot size is so I need to compare num to which two numbers. I need to compare this to, let's say if there is 98 coming, I should compare it to the top of half 1. If it is greater, then push it here, right? If it is smaller, then push it here, right? Am I tripping? So if, let's say if there was 2 coming here, now 2 is less than 12, right? 2 comes here. Yeah. If num is strictly greater, can there be yeah, that it doesn't matter. If num is greater than half 1 dot top, it should be going to half 2 dot push num, else half 1 dot push num. Now there are things to consider here. If half 1 and half 2 are imbalanced, let's write one function here, balance. Should be private void balance. If half 2 dot size is greater than half 1 dot size, half 1 dot push half 2 dot top, half 2 dot pop. Else if half 1 dot size is exceeds by 2 is greater than half 2 dot size plus 1, then half 1 2 dot push half 1 dot top, half 1 dot pop. If they are equal, we don't need to do anything. Half 2 dot size plus 1, this is correct, right? If half 2 dot size, it can have 1 extra, but if it is more than 1 extra, then we should balance them. Okay, let's see now. So in median, we simply get the we need to keep track of n as well. N is simply half 1 dot size plus half 2 dot size. Int n equals half 1 dot size plus half 2 dot size. If n mod 2 is odd, then return half 1 dot top, else return cast it to double, half 1 dot top plus half 1 2 dot top divided by 2. Let's see if this is any good. What happened here? Priority. Shit. Vector int greater int, but that was not the problem. That no template priority. Spelling mistake. Priority queue. This is a min heap, by the way. Reference binding to null pointer type. Shit. Okay. Okay. So one thing to notice here is if half one dot size dot is empty, then push it to half one dot push half one dot push num, and that's it, return. Let's see if this was the problem. Okay, so the sample test case is working. This solution is pretty simple. Let's see if it can handle many test cases, or I don't know, man. Yes sir, it accepts it. Now maybe if I keep track of n separately, I can improve this. I don't know. Let's try that. Let's try int n equals 0, and at everything n plus plus, then I don't need n. What? Shit. Yeah, slight difference. Doesn't matter much though. Let's see some of the faster solutions. It's pretty much the same, I believe. Yeah, it's pretty same, man. But my code is, I mean, kind of good, modularized. I have a balance function separate, which I invoke after every addition to the data stream. So yeah, it's fine, man. It's good. Okay, let's crack on some different topics now. I have done heap, backtracking. Okay, before backtracking, I should do some more recursive things, right? Okay, I'm back. Okay. Okay, let's do. What should we do, man? Binary search? Let's do binary search. Given an array of integers nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. I should do this like with my eyes closed. Int l equals 0, r equals nums dot size -1, while l r n equals if target equals nums of m, return m, else if target is greater than nums of m, l becomes m plus 1, else r becomes m minus 1, return -1. 2, should this be equal? I don't know. It shouldn't be, right? Shit. If it is equal, yeah, it should be equal. Fuck, I messed up. I messed up binary search. Fuck me, man. I should be fucking... Okay, let's get the second one. Search a 2D matrix. Now this is pretty fire question. I was stuck in this question for a long time when I first attempted this. You are given an m by n integer matrix with the following two properties. Each row is sorted in non-decreasing. The first integer of each row is greater than the last integer of the previous row. What? Ah, okay. You must write a solution in order of... Okay. So basically we need to convert this into a single list. I mean, sort of, we have to imagine that this is a single dimensional list and we have to apply binary search on that. So if you see here, damn. Okay, 0, 1, 2, 0, 1, 2, 3. Can I derive some formula to get the row and column if I just give you like, okay, let's see, 0, what, 1, 2, 3, 4, 5, this is a 5, 6, 7, 8, 9, 10, 11. Now can I convert this one to 0, 1? How can we do that? We simply we already know that m is 3, which is the number of rows, and n is 4, right? So if I divide this index 1 by m, down, I should actually divide this by n to get the row count, right? If I do yeah, 1 by 4 is 0. It is, so it is the 0th row, and 1 by 3, 1 mod 3 should be the answer. So it is in first column. 5 mod 3 is... Nah. Okay, I messed up. I messed up pretty badly. Okay. From the pattern I can guess, right? To get the 0th column, I have 0, 4 and 8. So the index I should be modded by n to get the column, right? But to get the row, what do I need? 3 by 4 is still 0, but 4 by 4 is 1, 8 by 4 is 2, 5 by 4 is 1, 6 by 4 is 1. So there is no need of m in here. just n would work fine, right? But why is that the case? Let's see, let's try, man. So we have a target, m equals matrix dot size, n equals matrix 0 dot size, int l equals 0, r equals m times n minus 1, while l is less than equals r, int n equals l plus r by 2, int rho equals, what was our rho formula? I by n, right? What is I? M, right? M by, shit, should be mid, let's call it mid by n. Col equals mid mod n. If matrix of row col is target, then return true, else if target is greater than this value, then L becomes m plus mid plus 1, else R becomes mid minus 1, return false. Let's try this on the sample test case. Okay, it works fine. Let's see the actual submission. Cool. The next one, Coco eating bananas. Coco loves to eat bananas. There are n piles of bananas. The ith pile has piles I bananas. The guards have gone and will come back in each hours. Coco can decide her bananas per hour eating speed of k. Each hour she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly but still wants to finish eating all the bananas before the guards return. Return the minimum integer k in such that she can eat all the bananas within 8 hours. So yeah, this needs binary search. At first, you might simulate this shit, but yeah, you might think fucking recursion and fucking DP and stuff like that, but it is simply a binary search. Binary search and trial. Trial means a dry run, that's all. Dry run through code. Simulate the situation. Alright, let's see. I'm just making sure one thing. I'll be right back. All right. Okay, so for example, let's take this seems a pretty complicated example. Let's pick this. So these are the piles of bananas, and we have Coco K here, and Coco has 6 hours to finish all of these piles. So what do we need? We need bananas per hour speed. We need to calculate how many bananas per hour she needs to eat minimum to finish all of these piles of bananas. I can pick 30, right? Now what should be the maximum bananas that she can eat? I mean, she can try with the minimum of these. Like, okay, my left can be 4 and my right can be 30. That can give me the answer, but what should be the ideal thing? I mean, she can eat 1 also, but yeah, it's whatever. Do we have anything here. K bananas from that pile. Param param pam, param param pam. Should I get the maximum from these? Seems like pointless to me, because pile's length is 10 to the power of 9, so I don't give a damn, brother. No, 10 to the power of 4, so 10,000. I don't want to get the maximum. Okay. Should I get the maximum? I'm not sure, man. Or should I just do piles of I can be 10 to the power of 9 actually, so that is boom boom. I mean, minimum and maximum can help a lot, but I'm still wondering if I do need them. Can I start with the 1 and fucking this value? I can, but it will you know, it can be bad. Let's look at my previous solution. What did I choose as left and right? Piles of n minus 1. Just the last value? How does that work? Is piles in an increasing order? No, it isn't. Or have I sorted it? Sort, okay. We are sorting. Why do we need to sort them? Why are we sorting this shit? Okay. Why? Yeah, that's why this is the thing, because I'm sorting it, man. Fuck. Let's look at some good solutions to see what they have taken. Yeah, max of piles. So he is getting the maximum. Okay, let's do the same thing. Get max element from vector C++. I think it's just max element. Yep. It returns a pointer to that value. So okay. Int L equals 1, R equals max element from piles. Bool if can eat at m rate, can Coco eat all of the piles, then k becomes m. If she can eat, so I need to reduce the rate, so r becomes m minus 1, else L becomes m plus 1, and at the end we return k. Now I just need to write this function can eat, so it will be a bool function where m is the rate of eating, and this is just piles. and I need h as well, so h is the limiting factor of number of hours, so I need to pass that. Okay, so in here we simply calculate the number of hours needed to finish all of these bananas. Count, we start with 0 hours for int bananas in piles, count plus equals, if there are b bananas and rate of eating is r, what is that ceiling function, right? Ceil, so we need to do a ceiling of bananas divided by rate of eating, right? Should bananas be double? Let's do it double, no worries. If count exceeds h, then return false, else return true. Let's see. No matching function for call to max element. What happened, brother? What's wrong? Max element in CPP. Oh, we need the starting index and last index. Okay. Begin. Okay, this works on the sample test cases. Let's see if actual submission works. Yep, it works. Pretty good question, pretty creative one. Okay, let's get this. Find minimum in rotated sorted array. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array this might become this if it was rotated 4 times, if it was rotated 7 times. Notice that rotating an array results in, okay, so we are doing a clockwise rotation kind of thing, so the last elements come at first. Given the sorted rotated array of norms of unique elements, return the minimum element of this array. You must write, okay, now this is a tricky one. This is a tricky one. When I first attempted this, I wasted a lot of time. Let's see if I still waste a lot of time. Let's see. So we have a rotated array. Pivot point is this, basically the origin. This is 0, 1, 2, 3, 4, 5, 6. Okay. Okay. Okay, we can do a binary search with left and right starting here. And let's get the m value. So 0 plus 6 by 2 is this. So m is this. Now I see that m is greater. The value of m is greater than m minus 1 value, but it is also greater than m plus 1. Right? So what does this mean? This means that m is the last element of that sorted list, right? Now there can be many cases here. M could be here. So when this is the case, so m is in a linear fashion, right? Now at this point, I don't know where that pivot point lies, right? M could be here, so this is the same case. So two cases appear in this one. M could be here, where m is less than m plus 1, but it is also less than m minus 1, so m is the actual pivot point, so this is the answer. In this case, m plus 1 was the pivot point. Now in this case, for this is a special one, this is a tricky one. How do I know where to go? Do I go left or right? For this, I can check if m is here. I can check if m is greater than the last element. Yep. In this, if another condition is if m is greater than last element, then go right. So L becomes m plus 1. Else m is less than last, so R becomes m minus 1. That's all we need to do. Let's write this function. Int L equals 0, R equals nums dot size, while L is less than equals R, m equals L plus R by 2. Let's first write the ending condition, these two basically, right? This is actually the ending condition in an ideal case. Okay, if m could be 0, right? Okay, let's do some shenanigans here. Left. If m minus 1 is greater than or equals 0 question mark, then nums of m otherwise. Basically I'm trying to see if m reaches here in any case, what's gonna happen. Should I put 2 here? Yeah, makes sense. Otherwise it is in negative, so it should be nums of okay, I need to attend a call. I'll be right back. Okay, I'm back, boys. I'm back. Let's get this done. Let's get this question done. Okay, where was I? Okay, I was calculating left and right of this thing. So m plus 1, if it is less than n, then nums of m plus 1 should be m minus 1, otherwise nums of 0. Now we simply check this condition, right? If left is greater than nums of m and nums of m is less than right, then return m. Oh, sorry, nums of m. If yeah, I can even write this condition, man. Yeah, if left is less than nums of m and nums of m is greater than right, then return right. If left is less than nums of m and nums of m is less than right, now there are two conditions here. If nums of m is greater than last, which is nums of n minus 1, then what do? I'm pretty sure there will be some corner cases that will completely abolish the algorithm that I've just made. So I don't even care anymore. So left becomes m plus 1, otherwise else r becomes m minus 1 at the end. Let's return nums of l. I don't know. I'm just okay. It is passing the sample tests. Let's see the actual submission. I'll be surprised if this gets accepted. Yep, I knew it. Okay, now time limit exceeded. Why is that the case? 0 0 0 plus 0. Oh shit. Okay, if n is 1, return okay. Now one thing to notice here, there is no else condition, so yeah, return nums of 0. Let's see. There will still be a fucking edge case. Oh yes, I'm kind of a genius. Fuck this question, brother. How did I do that? That's crazy. I mean, I wrote a code that I don't even understand myself. Let's see my previous solutions 2 years ago. Oh fucking hell, brother. Okay, seems pretty small. If nums l is less than r, return nums l. M is l plus r by 2. Nums of m is greater than nums of l. L equals m plus 1, r equals m. Pretty confusing, if you ask me. But this solution works. I'm pretty surprised. Like, I did some drawings here and it works. What the fuck? That's crazy, yo. Beats 100%. Let's see some other solutions. While left is less than right, mid. If nums of mid is greater than nums of right. I may have made my solution a little bit complicated. Might be straightforward. Okay, if left is mid plus 1, nums of mid is greater than nums of right. Left becomes mid plus 1, correct. Otherwise, right equals mid. Okay. Even this works. That's pretty good, but alright. I mean, I'm happy with what I did here. Pretty logical. I basically calculated all the probabilities, like all the possibilities of M, where it can be, and I just did my thing. That's what I do, man. Okay, let's get the next one. Search in, find minimum, search in rotated. Now this is a question that is tricky, right? Now I just need to search. Can I take my old code and just do a fucking tweak here, tweak there, and it'll be good to go, I believe. I'm just trying to search here, right? If it is in here, then we return Okay, let's write this function, man. Copy code, paste, left, right. Okay, now instead of doing all of this garbage, okay, if it is minimum, why do I get tired of after fucking 4 questions of lead code, man? Int left is what? Now target comes into the picture. I need to find the target here. Fuck it, man. I'm taking my last solution. Okay, LR, while L is this, calculate M. If it is this, then M. Return if nums of L is less than equals nums of M. One thing, key thing I missed in that question, that all of the elements are distinct. That was a big hint. If target is greater than nums of L and target is less than nums of M. If target is greater than nums of L and target less than nums of M. So R becomes M minus 1, else L becomes M plus 1. Now if we are in a case where nums of M is less than nums of R, what do we do? Nums of M is less than nums of R. Now, yeah, we are in that part, right? Okay, so it is guaranteed that either this condition will be true or this condition will be true, right? If nums of L is less than nums of M, yeah, makes sense, it can be true. And nums of M is less than nums of R. Nums of M is less than nums of R. Yep. Then nums of L. Let's say if M is here, nums of M is less than nums of R. Let's say if M is here, nums of L is less than nums of M. Yep. Okay. Now if target lies in between them, then we reduce R, otherwise we say that it moved to the next half. If target lies in between them, m and r, then we say l becomes m plus 1, r becomes r minus 1, return minus 1. Okay, makes sense, makes sense, makes sense. Okay, so we can't do this shit. Let's write another binary search. What a day, man. While l is less than equals r, int m equals l plus r by 2. If target is equals nums of m, return m. Now if we are in the first half of the rotated sorted array, which means the leftmost thing is less than equals m. And does it say distinct? With distinct, so why am I doing equality? So if nums of l is less than nums of m, if target lies in between them, if nums of l is less than equals target and target is less than equals nums of m, then r equals m minus 1, else l equals m plus 1. Else if nums of m is less than nums of r, if target lies in between them, nums of m is less than equals target and target is less than equals nums of r, l becomes m plus 1, else r becomes m minus 1. Minus 1. Okay, I messed up. Okay, still bad. I'm missing something here. If nums of l, that's why equality was there, because L and R can be equal, so M can be equals R. That's why this equality is there. Everything has a reason. Everything has a reason, man. Damn. Okay, let's get to the next one. Time-based key value store. Okay. Design a time-based key value data structure that can store multiple values for the same key at different timestamps and retrieve the key's value at a certain timestamp. Implement time map class as follows. Initializes the object of the data structure. Set key value and timestamp. String get key timestamp. Returns a value such that set was called previously with timestamp previous less than equals timestamp. If there are multiple such values, it returns the value associated with the largest timestamp. If there are no values, it returns this. So it kind of returns lower bound, right? Yeah, not greater. Lower bound, timestamp, key value. Okay. Okay, I get it. So I think I can make two hash maps, maybe an ordered map of string to string value map. Let's call this data, and let's call this, should I take a vector or just a set? A set makes more sense because it keeps them sorted, right? Time data, right? What do I need to return actually? Returns a value. Oh, that's crazy. Okay, so this set should contain a pair. I should combine these two fucking data structures. What the fuck? That's crazy. So it should be ideally this, and we don't need this then. Key maps to time stamp and value. Set of pair, actually pair of intent string. And I need to fucking shit. I can't sort. I mean, I can. I need some comparator for this set, or instead of creating a pair, I can make a custom object, which will be easier to handle, maybe. But if I can, let's ask ChatGPT, man. Set a custom comparator for a set in C++, set of pair of int string. It should order by the int value. Okay, we create a structure, we override the this operator, we compare. Okay, is that it? Okay, that's it. That's what I need to do. Struct compare by timestamp. Bool operator const pair of int string, a const pair of int string b, return a dot first should be less than b dot first, and this comparator I should be passing in here compare by timestamp. Now in set simply instead of time data, I'll just call it data because there is no other data structure. Data dot if data dot find key is equals data dot end. Is it get? I forgot. Unordered map in C++, find and get. Yep, it is find. If this is empty, then data dot data of key insert into this map. Using insert dot insert this okay, using emplace. What is the slightly more efficient for complex types constructs in place? Okay, data dot insert key and a pair of timestamp and value. No. Data, if it is empty, then data dot insert key new set, right? I have this. I can directly insert. I don't need to create a new set. That's crazy, man. That is absolutely crazy. So I just do fucking time stamp and value. Is that it? Are they distinct? Okay, what if the key exists already? Fuck it, man. Fuck it. Do 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 do. Do 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 do. In a get, we get set of pair. No. Vector of. Now Java shines in these kinds of cases, man. Java is pretty powerful. Sorted list. Data dot get key dot set to vector in C++. Okay, pretty easy. Data dot get key dot begin, data dot get key dot end. Right now I just need to do binary search on this sorted list, right? Or can I do lower bound on this? Can I do lower bound on this vector? Safe and sound. Safe and sound. Okay, let's try this. Auto ID equals lower bound of sorted. Let's call it just fucking array, man. Array dot begin, array dot end. Messed up here. Make pair. What am I doing, brother? Damn. Make pair. Now key is this string. Oh shit. They don't like us. They not like us. They not like us, man. Time stamp. Now this syntax is pretty hard to understand. First of all, I'm kind of doing some sort of operator overloading. I don't know, man. What the fuck am I doing? I'm just copying from ChatGPT. Otherwise, I could have done a manual binary search. You know what I mean? It's fine. I've done that already. I'm just trying to get some style points. Now if it doesn't exist, what should I return? If it just returns an empty string. If id is not equals array.end, return it second, right? Return empty. Let's pray. Okay, fuck. No matching member function for call to insert this. Let's just fucking do this, man. No member name yet. What? Java has plagued my brain. Now if data dot find key is equals data dot end, return an empty string. What the fuck? Data key insert this. What happened, brother? Should I create a new set? Safe and sound. Automatically creates an empty this if some key doesn't exist yet. Oh, C++11, is this C++11? I hope so. What the fuck? I mean, this should have worked. What's the problem here? What's the problem here, officer? What's the problem here? Hash function in instantiation compared by times an operator this requested here data key. What? I'm so confused. Let's look at my previous solutions. Oh, I haven't done this before. That's crazy, man. Requested here in instantiation Let's throw this into Chat GPT. Oh. Oh, shit. That's crazy, yo. Then what's the problem again? Comparison object must be must be invocable as const. Should this be in public? Is that what you mean, brother? What? Pam pam pararam pam pam pararau pam. What? What the fuck is happening? Member function time map compare insert requested here. Insert. Yeah, that's what I'm doing, man. Insert requested here. Static assertion failed due to basic string. Comparison object must be invocable as const. Okay, struct compare this, bool operator this, const blah 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 const. Oh, this is interesting. Okay, wrong answer. Wrong answer. So this lower bound is pretty bad, I believe. Let's do a manual thing, right? Int L equals 0, R equals array dot size, while L is less than equals R. Now target is timestamp, right? Int M equals L plus R by 2 if timestamp is equals array of M since this contains this, then return what? Yeah. Else if array M dot first if t is less than oh shit. Okay, messed up. Save and sound. Caught in a bad romance. Hi, bro. Where are you from? I'm your 96th sub. I'm from India, brother. Hello, Andrew. Andrew Karev. Thank you for subscribing. Currently doing a bunch of lead code questions. That's all. That's what we do here. So, yeah. Where are you from, Andrew? Okay. What the fuck? Int equals v m dot first. What the fuck is happening? Let's print this m. Oh shit. Shit. I'm bad at this. Okay. It's not returning the value, but okay. It has to return something, right? So lower bound. So let's do this way. Int m, and then at the end return array of m dot second. Is that what you mean, brother? Yeah. I'm from Russia. Nice. 44 cases passed. What happened here? Some empty shit. I'm just down to look at some fucking solutions, man. This question, I have made this way too complicated in my opinion. Let's look at some solutions. C++, 3 lines. And how many lines have I written? More than 30. Okay, let's see what happened. This doesn't count, man. You're just... okay. A map of int string. Unordered maps key to value and... no, timestamp and value map. Instead of set, he's taking a map. Then in set key insert this. Upper bound timestamp. Return... Caught in a bad romance. What happened here? Null, high, low. What? Should be L, right? And not M. I mean... fuck. Okay. L is 0 question mark, then empty, otherwise this. If L is whoa, caught in a bad romance. Wah. Yeah. So I can do an upper bound on map. What? Since our timestamps are only increasing, we can use vector instead of a map, though it's not as concise. Okay, we are pushing back here. Auto IT upper bound. Pair of in-string timestamp this, then the comparator. Return IT if it is begin. Oh, he's calculating upper bound. Why is that the case? Caught in a bad romance. Oh. Okay, let's undo some shit. So lower bound was not the shout. You know what I mean? Lower bound was not the shout. It has to be upper bound. And I have to return if it is array.begin, then return an empty string. Otherwise, return the previous iterator and the value of that. So value is in the second. Let's try this. Is this problem from NeetCode roadmap? Yes, it is. Yes, it is this one in binary search, time-based key value store. Question 981 on LeetCode. Caught in a bad romance. Okay, this works, but this guy is saying that timestamps are only increasing. Is it written somewhere? All timestamps are strictly increasing, so we don't care about this vector, right? Right. Then we don't need this garbage, right? And then we simply insert this, and then we simply get this. We don't need this. Array equals. Is that it, right? Pushback. Instead of insert, it should be pushback. Is this tagged as hard? It is medium. Yeah, it seems like medium. Yep. Okay, I still don't understand. I'm absolute beginner in LeetCode. Just started this roadmap. Yeah, it's a nice list of questions, man. It has all types of questions like easy. You can get started with some of the easier ones. If you're still not confident, you can do more easy questions not from this list. Or maybe I think he has now 250, even 700. So just go through all of the easy ones. That's fine. Okay, time limit exceeded here. How can we improve time here? Upper bound, const. How can we improve time? Now this is binary search. This is order of 1. Maybe this copying of data is causing this. So instead of this, let's just... Okay. Let's just do this, man. Okay. Hopefully that might have solved the thing. Still TLE, I believe. No. Okay. Okay, I need to understand some of this. So we do an upper bound on we create the target pair, and then we write some sort of operator overloading function here. We compare, and that's all. Interesting. Hopefully I will remember this syntax in interviews. Let's see. So okay, binary search is done. Pretty good. How many questions? 49 are done. Cool. I can do another set tomorrow. Maybe graphs and shit, you know. I won't be doing I don't know, man. Bit manipulation. I hate these kinds of questions. So my focus should be on graphs, and then advanced graphs. Advanced graphs is okay. Yeah. Graphs, and then these two, and then advanced graphs. That should be the order, because I'm not sure these are asked in interviews. I mean, they are pretty hard, but let's see. I also need to revise the algorithms related to these. So yeah, cool. Okay, pretty good, pretty good. Good going so far. All right, so this was a good stream, man. Very productive stream. Did a lot of questions. So I'll be back tomorrow, hopefully, with more solutions. Until then, goodbye and GG's, man. Let's go. All right, bye bye.